So let's go ahead now and write our first NUnit tests from scratch. So in this demo, we're going to go and create a new project to hold our tests. We'll then add a reference to our production code project so we can actually test it. We'll install the NUnit testing framework NuGet package, and then we'll go and write a test class and add some test methods. So let's head over to Visual Studio. And if we have a look at the Solution Explorer here, we can see we've got our production code here, our calculator project, and inside this we have a simple calculator class here, which has an add method and a multiply method. And note here we've got this bug for demo purposes. So let's go and write some tests for this simple calculator class. The first thing we're going to do is we're going to add a new test project to our solution. So we're going to add a class library project, and we're going to call this calculator tests. So we'll just OK that. And now we have our test project. So we need to add a reference to our production code from our test project. So I'll just go to add reference here and tick the reference to our calculator project. So let's go and write a test fixture class now. The first thing we need to do is install NUnit. So I'm just going to use manage NuGet packages here. And online I'm going to search for NUnit. And I'm just going to install this main NUnit NuGet package here. Just hit install. And that's NUnit installed. So we can now make use of the NUnit attributes and NUnit asserts. So let's go over here and we'll rename this default class that we got in our new testing project. We'll call this calculator tests, matching our naming convention, and we need to mark this test class with the test fixture attribute from NUnit. And we can see here the NUnit.framework namespace has been added. I'm just going to remove these other namespaces to clear things up. So now we have our test fixture class that we can write tests inside. So let's start off with a first test. We'll start off by using the NUnit test attribute here, and we'll add a public void method, and we're going to call this should add two numbers. So that's our first test method. We now need to implement the actual test code. So the first thing we're going to do is create an instance of our system under test. And this is our simple calculator from our production code project. Just going to quickly rename this class so the file name matches. Now we've got an instance of our system under test, we can actually execute some behavior on it. So here we're testing the simple calculator's add method. So we're going to call our system under tests add method, and we'll just add the numbers 1 and 2 together. The final thing we need to do is add our assert to say whether this test has passed or failed. So we're going to use NUnit's assert.that method, and the first parameter we pass here is actually the result of running our production code. So here it's our result variable, which comes from calling our add method. The next thing we need to do is specify what the expected outcome is of running this method. So we want to choose is.equal to, and then the value we expect. Well, we expect when we add 1 and 2 together to get the value 3. And that is our first test. Let's just check that it builds, which it does. So let's go and add a second test to test the simple calculator's multiply method here. So again, we've applied the test attribute here, and our test is called should multiply two numbers. Again, we create an instance of our system under test. We then execute our production code here, and we assert that the result is as expected. So here we're saying that we expect when we multiply 2 and 10, we get the value 20. And we can just build. If we open the Visual Studio Test Runner now, and we can do this by going to the Test menu, heading down to Windows, and choosing Test Explorer. Notice that we don't get any tests showing up, and that's because we haven't installed the NUnit test adapter. So let's go ahead and do this. So we'll go to our tests project here, we'll go to Manage NuGet Packages, and online again we'll search for NUnit, and this time we're going to install the NUnit test adapter for Visual Studio 2012 and 2013. So by doing this, we don't need to install the Visual Studio extension. This package will enable the Visual Studio test runner to recognize NUnit. So let's go ahead and install this. And just close. And if we go to our Test Explorer now, we can't see any tests showing up yet, but if we rebuild the solution, we can now see our tests showing up. So there's a number of different ways we can order things. We can order them by class, duration, outcome, traits, which we'll look at in the final module, and also by project. So we've only got 2 tests here, so this is looking quite similar regardless of what we choose. Now we can go ahead and run our tests. So we can either run all of the tests in our solution here, we can right-click and just run all of the tests underneath our calculator tests project, or we can right-click on individual tests and run those. So let's start by running our should add 2 numbers test. So I'm going to right-click and choose Run Selected Tests. So now the test runner has executed the code in our test method, and we can see here that our test has passed because our assert was correct. And we can just prove that this is running by putting a breakpoint inside our test code here. And instead of right-clicking and choosing Run Selected Tests, we're going to choose Debug Selected Tests. So now our test executes, but this time in debug mode, so our breakpoint gets hit. So we can see our test is running, and we can see our result here from adding 2 numbers is 3. So our assert here that's checking for the value 3 will pass. Let's go and run this should multiply 2 numbers test now. So the test executes, and notice now that we've got this red cross and our test has failed. So if we look at the test output message here, we can see that our test assert expected the value 20, but was actually 12. So we can see down here, we're expecting the value 20, but we actually got 12. And that's because there's this deliberate bug here in this multiply method. We've got a typo here. We should be using the multiply operator. So let's just fix that up. We'll go back to our tests. This time I'm going to run all tests. And notice now that our multiply test passes along with the other tests in the solution.